Hello, good morning, good evening. We're going to talk about systems thinking today as part of the Essential Rainwater Harvesting course. And Michelle's here with me. I'm Peter Coombs. And this is actually my research area. So I'm going to take a lot of joy in talking about where we belong in the system and how we impact on the system. So here we go. I want to start with some issues that seem to be complex, but they need to be talked about. So this slide that I'm showing you is called a realistic solution space, and the two graphs on this space came from my PhD and also won national awards in Australia years later. So apologies, but they make a point very well. The top graph is an economic graph. It's costs and price versus quantity. And what tends to happen when you're doing small scale systems, it's assumed they have no benefit, no value. And that quite wrong assumption is usually based on the perspective of a smaller scale interest in the system. So here, that's the red dotted line is the costs and price for a private entity, say a water utility. And you can see they're only concerned with their own costs and price and profit, whereas the solid red line there is the cost to whole of society from getting water supply from a utility. And you can see there are very big differences between what society pays and what the utility pays. And those differences are known as the increased cost to society from this service that's not counted in the price of your water supply from your utility is what's known as a negative externality. So it's often claimed that small-scale systems have no real benefits, they don't make any difference. But that's only because that negative externality, which is the red arrow going upwards on there that's increasing the costs and price, is not counted. Of course, there are all sorts of negative externalities from water supply, which we'll talk about in this systems part of the course. Some of them is reducing flows in rivers and losing habitat and quality, taking water away from other parts of the community that are downstream. And there's a whole range of issues. So the blue arrows, let's start the blue lines. So the dotted blue line is demand, say, for water, demand for the private goods supplied by the water utility. But people are aware of that and they need to conserve water. So you have this positive externality, which is the blue arrow going to the left, and because they're conscious of the whole of society effects, and most people are in some way or another. So it changes that demand for that good to the dark blue line. And when you do things like rainwater harvesting, permaculture, that's reducing your demand on regional water resources, you're producing these positive externalities that's changing the cost and impact, but they're not counted in more traditional thinking. But if we use systems thinking, we are counting this because these things are real. And if we go down to the bottom blob, I call it, it was a conclusion out of my PhD. One axis, the vertical axis, is talking about environmental benefits, and the horizontal axis is talking about life cycle costs of water cycle services. So that means all the services provided by water, not just water supply out of your tap. The way we think in society, when we're trying to consider whether or not something has a benefit, is based mostly on, if it's water, on the utility thinking paradigm, which is that blue space, that blue blob. And when we say we've got the best answer, it's that black line at the start of it, closest to the environmental axis. So that's sort of the best answer for environment and costs. The problem is all these other things are not counted. That's the green part of it. So we're not getting the best cost or environmental answers because we're not considering the entire system. So when we take a systems perspective, we're saying there's no one best solution. For instance, if we do, we're probably not counting all of the other solutions that are in that green area at the bottom diagram. And in fact, there's a large solution space. Like there's lots of different things we can do, like distributed rainwater harvesting on properties, permaculture, on-site management of wastewater, change of behaviours. There's all sorts of things we can do. It's not about economic versus costs. In fact, when people are actually talking about economics in the water sector, they're usually only talking about costs, not economics. If someone says to you it's about a cost in dollars, actually not talking about economics, because economics is not about dollars, which is my economics professor told me years ago when I was doing my postgraduate economics. He said, if someone comes to you and talks to you about the dollars alone, they're not talking about economics, they're talking about financial analysis. So when you're actually doing things to change the behaviour of the system, you're changing the economics of the system. You're actually creating opportunity, and that opportunity is economics. So if you have a whole bunch of houses harvesting rainwater in a catchment, that's creating an opportunity to make the local waterway better, which no one's got a cost value for yet. And fortunately we don't, because if you lose that waterway, it has no value at all, or it has enormous value because future generations don't have that water. So we need to avoid averaged and siloed assumptions versus cumulative and connected. So average and siloed is not systems thinking. Cumulative and connected is systems thinking. Everything's connected to everything else. This is what I'll talk about now.